621, we're going to use some logarithms to solve some exponential equations because of our little problem that we have. So I have, I think, 5 examples for us to go over. Right? So how can I solve exponential equations? So we're going to use some logarithms to solve those guys. So let's say they wanted us to solve, oh, that's a little on the thick side. S. Yep, I'm going to go with a solve. So they want us to solve the equation 1.04 raised to the x equals 2. So on this little problem, our problem is the fact that our variable is up in that exponent, and we need to be able to get that guy out of our exponent. So, and bring him out front. So anytime you have that variable that's up there in the exponent, we need to take the log of both sides, and then we can use some of those properties of logs to get that x out of there, right? So no different than any equation. If you do something to one side, you got to do it to the other side. So I'm going to take the log of the left side, and since I took the log of the left side, I have to take the log on the right side. And then I want to say it was last semester when we sat there and we were playing around with those properties of logs, and we went through all the different properties, the adding and subtracting. And we know that when it comes to, if we have an exponent and we take the log, we can bring our exponent and we can bring it out to the front. Remember that? Coming back to you a little bit maybe. So I can rewrite that as x times log of 1.04 equals the log of 2. Right? And what's my goal? I want to solve for x, right? So right now I have x times that log of 1.4. So I need to get rid of the log of 1.4. So I can divide both sides by the log of 1.4. Divide this side by the log of 1.04. Those babies are going to cancel each other out, right, or be 1. So then x equals log 2 of log of 1.04. So we're going to jump over onto Desmos. Let me. Yeah. And so on Desmos, to get to our logs, you have that main, that ABC, and that function. You got to squeeze over to function, and then it'll tell you log right there. So click that. So we had the log of 2, and that was divided by the log of 1.04, right? Hit the little enter. What do we get? 17.67. You guys good with that? So 17.67. So all of the same principles kind of apply when it comes to solving any regular equation. When it comes to moving things around. But the good, nice thing with taking logarithms, it gets us that x out of our exponent. All right, a couple more for you. So solve the following equations. Oops, let me make it a little bit bigger for you. And then after checking your answer, round them to 3 decimal spots. All right. So here I can rewrite A so you can see it a little bit better. So what do we got? 5 equals 2.25 raised to the x, right? Where's our variable? In the exponent, right? So the only way we know how to get rid of that is by taking the log of both sides, right? So we're going to take the log of the left, and if we take the log on one side, we got to do it to the other side. And then our power property of logs tells us whatever is up in our power, we can bring that guy out front, right? So now we got log 5. Bring our x out to the front of log 2.25. Right? We want to solve it for x, so we want to get rid of the log of 2.25. Divide both sides by 2.25. Divide by the log of 2.25. Log of 2.5 over log of 2.5 is going to be 1, so that guy is going to cancel out. So plug that guy into decimals. We have the log of 5 divided by the log of 2.25. And it says to round it to 3 decimal places. Can you guys see that? So what are we gonna get?
196. I can't see that.
1, yeah, 9, 8, and then our 4 is gonna go up to a 5. Yep. Boom. Got it for you. All right. How about you guys try B for me? So B was 3.5x equals 10. All right, I got 2 more for you. So for C, they have 2 times 8 to the x equals 1.28. So kind of again, just looking at the problem, we know that our variable is in the exponent, so we know we're going to have to take the logarithm of both sides. But we want to try and get whatever that base is raised to that exponent. We want to make sure that's by itself as much as possible before we take the log of both sides. So on our problem C, 2 times 8 to the x equals 128. What do you think the first thing we're going to want to do is? Instead of, well, we can't distribute it.
Well,
Yeah.
I'm paying attention for like multiply.
Yep. No, you're fine, yep. So, because this is 2 times 8 to the x,
Yeah.
we're going to divide both sides by 2.
That's okay.
Yeah,
That's okay. I knew that. Yep. I knew that's what you were thinking,
It's all
right? It's all right. So we get 8 to the x equals 64, right? So some of you might know what this answer is automatically without even taking the log of both sides.
Is it an 8?
It's 8 to the 2nd.
8 to the 2nd, yeah, x is 2, right? 8 squared is 64, right? Yep. So if you can see that on these problems, by all means, you can tell me that x equals 2. If not, you're going to take the log of both sides, right?
So for the assignments, do we have to write out all the steps and stuff?
Like on this one, you would have to at least probably tell me like this part, right? And then on that one, you knew that it was 2, then you're good to go, right? But I would say if you just looked at that original problem, just looking at it, before you divided it by 2, you wouldn't know that it was going to be 2, right? And you'll get the same answer. So I know I can bring my x out front of log 8 equals log of 64. X is going to equal log of, 64 divided by the log of 8. And when I put that into my calculator, I'm going to get x equals 2. All right. So let's look at D real quick. So for D, we have 2x to the 8th equals 128. What do you think we should do first on this one?
Divide.
Yeah, divide by 2, right? So we got x to the 8th, that's an 8, equals 64, right? Now what are we going to do?
Log thing. Log.
Are we going to take the log of this one?
Yeah, he's right.
Yeah. Where's our variable? Is our variable in the exponent?
You gotta,
Take the,
you,
yeah, we gotta take the
Put two in.
eighth, yeah, we gotta take the eighth root to both sides, right? So this is where we just gotta be careful when it comes to our problems, right? We're only taking the log if our variable is up in there in that exponent, right? This one's not our exponent, this one's actually our base. So in order to get rid of that eighth, we're gonna take the eighth root of both sides, right? So kind of like the square root, but it's gonna be the eighth root of x to the eighth. So that means you gotta take the eighth root of 64. Take the eighth root of x to the eighth, you're just gonna get x, right?
shouldn't it be 2?
Should it be 2?
I think so.
You think so? Right?
Or it's gonna be 8.
Yeah.
Square root of 8 is, or 6.
Yeah.
That should be 8.
Should be 8. We'll see.
Wait, no.
Yep, so there is this little button where you're taking that nth root of something, right? So ours was the 8th root of what number? 64. You ready? Boom.
Oh, it's right.
1.6.
Yeah.
Good number.
So what do we get? 1.682?
I guess that was right.
You guessed that right? I'm so proud of you, so proud of you.